Experimental scored a staggering 73.3% on the AIME 2024 math benchmark, nearly doubling its previous version's performance. But can Google finally overtake OpenAI in the AI reasoning race? Is Google about to change the AI game forever? The battle for AI supremacy has reached fever pitch, with OpenAI's reasoning models setting benchmarks that seemed unbeatable until now. Google's latest Gemini 2.0 flash thinking experimental isn't just another model update. It's a fundamental rethinking of how AI processes complex problems. What makes this release particularly significant is how it showcases Google's multimodal strengths in a single package. Not only does it match OpenAI on reasoning tasks, but it brings image generation capabilities that could make other tools obsolete. The question isn't whether Google can compete anymore, it's whether OpenAI should be worried. Welcome to the AI Uplift, where today we're examining what might be Google's most important AI release of 2025. Google's path to challenging OpenAI in the AI reasoning space hasn't been straightforward. Despite having some of the world's most talented AI researchers and nearly unlimited resources, Google has consistently found itself playing catch-up to OpenAI's headline-grabbing releases. The first major challenge has been one of perception. While Google pioneered many foundational AI technologies, OpenAI captured public imagination with ChatGPT's December 2022 launch. Since then, OpenAI has maintained its position as the perceived innovation leader, with each new release setting benchmarks that competitors scramble to match. Google's Gemini models, despite impressive technical specifications, have struggled to shift this narrative. Google also faces a product integration challenge. OpenAI has focused almost exclusively on AI, building a streamlined ecosystem with clear product differentiation. In contrast, Google must balance AI innovation with its vast array of existing products and services. This creates a complex decision matrix about where and how to deploy new AI capabilities, often resulting in fragmented user experiences across Google Search, Bard, which later became Gemini, and various workplace tools. The technical challenges are equally daunting. Creating models that excel at reasoning, the deliberate step-by-step problem-solving that humans perform, requires fundamentally different approaches than traditional language models. OpenAI's O1, and particularly the O3 mini models, have demonstrated remarkable reasoning capabilities, especially in mathematics, science, and logic problems. For Google to compete, they needed not just to match these capabilities, but to find ways to differentiate. Perhaps the most significant challenge has been balancing speed and accuracy. Reasoning models typically sacrifice generation speed for improved accuracy, making interactions feel sluggish compared to standard chat models. OpenAI addressed this with specialized inference optimization, but Google needed to find its own approach to make reasoning practical for everyday use. There's also the matter of context window utilization. While Gemini 1.5 Pro offered an impressive 1 million token context window, the practical benefits were limited by the model's reasoning capabilities. Simply having access to more information doesn't help if the model can't effectively reason about complex relationships within that information. Finally, Google faces the expectation challenge. Each new release is measured not just on its absolute performance, but against the sky-high expectations of both the market and Google's internal standards. With competitors like Anthropic, DeepSeek, and Meta also making rapid advances in AI reasoning, the company needed something truly distinctive to stand out. The introduction of Gemini 2.0 Flash Thinking Experimental represents Google's attempt to address these challenges head-on. Rather than simply matching OpenAI's models, Google has taken a different approach, combining reasoning capabilities with multimodal understanding and generation in a single model, while optimizing for chat interactions. It's a bold strategy that recognizes Google can't win by playing exactly the same game as OpenAI. But perhaps the most interesting challenge Google faces is explaining the value proposition of reasoning models to everyday users. While benchmarks and test scores matter to AI researchers, most users care about how these advances translate into solving real-world problems. By integrating tools like search, maps, and YouTube directly into the reasoning process, Google is betting that practical utility will matter more than benchmark dominance in the long run. Gemini 2.0 Flash Thinking Experimental represents a significant evolution in Google's AI strategy, combining several key advancements that differentiate it from competing offerings. At its core, this model introduces what Google calls structured reasoning, an approach that makes the AI's thought process visible and systematic. Unlike standard language models that prioritize fluent output, Flash Thinking explicitly breaks down complex problems into steps, evaluates multiple approaches, and shows its work. This is particularly evident in mathematical and scientific reasoning tasks, where the model achieved a 73.3% score on the AIME 2024 benchmark, dramatically higher than Gemini 1.5 Pro's 19.3%. What makes Gemini 2.0 Flash Thinking particularly interesting is its multimodal foundation. The model can process both text and images as input, enabling it to reason about visual information such as charts, diagrams, and photographs. This allows users to simply snap a picture of a math problem, technical diagram, or complex document and have the AI reason through it step by step. Perhaps most surprisingly, Google has expanded the model's capabilities to include image generation and editing. Users can describe modifications to images conversationally, create variations, change perspectives, or even generate new images based on textual descriptions. Early user reports suggest particularly strong performance in maintaining contextual details and textures, with some noting the model's ability to preserve specific elements like product labels and barcodes when editing images. Speed has been another focus area. Despite the increased reasoning capabilities, Google has optimized inference to make the chat experience noticeably faster than competing reasoning models from OpenAI and DeepSeek. This addresses one of the major limitations of reasoning models, that their deliberative nature typically makes interactions feel sluggish. The integration with Google's other services creates a powerful knowledge ecosystem. When reasoning through questions that require current information, Gemini 2.0 Flash Thinking can automatically leverage search, maps, and YouTube to fill knowledge gaps. This helps address the model's June 2024 knowledge cutoff, though early testing shows it doesn't completely eliminate inaccuracies. Accessibility has been prioritized as well. Unlike some advanced AI features that require premium subscriptions, Google has made Gemini 2.0 Flash Thinking Experimental available to all Gemini users through the drop-down model selector. This democratizes access to advanced reasoning capabilities, though Google notes some features may not be compatible with the experimental model. Google has also designed the model with developers in mind. Available through Google AI Studio and the Gemini API, Flash Thinking gives developers access to structured reasoning capabilities they can integrate into applications. The massive context window, supporting up to 1 million tokens input and 64,000 tokens output, enables applications that reason over entire books or research papers while maintaining coherence. What's particularly notable is how Google has positioned this release within its broader AI strategy. Alongside the consumer-focused Flash Thinking model, Google introduced Deep Research for Gemini Advanced subscribers, an agentic system that conducts multi-step web research on complex topics and generates comprehensive reports. Together, these releases signal Google's vision of more autonomous, capable AI assistants that can handle increasingly complex tasks with minimal supervision. While Gemini 2.0 Flash Thinking Experimental still has limitations, including occasional inaccuracies, a fixed knowledge cutoff, and some image generation inconsistencies, it represents Google's most compelling answer yet to OpenAI's reasoning models. Rather than simply matching OpenAI feature for feature, Google has created something distinctive by unifying reasoning, multimodal understanding, and generation capabilities in a single, accessible model. Google's Gemini 2.0 Flash Thinking Experimental represents more than just incremental improvement. It's a fundamental strategic shift that could finally give Google the edge it needs against OpenAI and other competitors. The breakthrough moment comes from Google's decision to unify three critical capabilities that have traditionally been separate: advanced reasoning, multimodal understanding, and image generation. While competitors have excelled in individual domains, OpenAI's O3 Mini for reasoning, Claude for multimodal understanding, Midjourney for image generation, Google has created a single model that performs impressively across all three areas. This integration enables entirely new workflows that were previously impossible. Consider a data analyst who uploads a complex chart, asks Gemini to identify trends, requests clarification on unusual patterns, and then asks the model to generate a modified visualization highlighting key insights, all in a single conversation. No switching between specialized tools, no context loss, just a seamless problem-solving experience. What makes this particularly significant is how it leverages Google's unique strengths. While OpenAI has partnered with Microsoft for search capabilities, Google has integrated its core search technology directly into the reasoning process. The model doesn't just access information, it knows how to formulate effective search queries, extract relevant details, and incorporate them into structured reasoning flows. When combined with Maps and YouTube integration, this creates a knowledge ecosystem that competitors simply can't match. The speed optimization is another game-changing element. Reasoning models typically force users to choose between quick, fluent responses and deep, accurate analysis. Google has somehow managed to maintain reasoning quality while dramatically improving response times, making flash thinking feel responsive in chat environments. This could significantly increase adoption rates, as users are notoriously impatient with sluggish AI interactions. Perhaps most strategically important is Google's decision to make this technology widely accessible. While OpenAI reserves its most powerful capabilities for premium users, Google has made flash thinking available to all Gemini users through a simple drop-down menu. This democratization could rapidly expand the user base familiar with reasoning models, potentially changing expectations across the entire industry. The image generation capabilities represent the most unexpected dimension of this release. By adding conversational image editing directly into the reasoning model, Google has eliminated the need to switch between different specialized AI tools. Early user reports suggest the quality rivals dedicated image generation systems, particularly for editing and contextual generation tasks. This isn't just convenient, it fundamentally changes how people will approach creative workflows. For developers, the combination of the massive context window, 1 million tokens, structured reasoning, and the stability of Google's infrastructure creates compelling opportunities. Applications can now reason over entire research papers, books, or code bases, extracting insights that would be impossible with smaller context models. The ability to generate both text and images from a single API simplifies application architecture and reduces costs. The timing of this release is particularly strategic. Coming after OpenAI's O1 and O3 mini models established the importance of reasoning capabilities, but before these approaches have become standardized, Google has the opportunity to redefine what advanced AI assistants should be capable of. By combining reasoning with multimodal generation, they've set a new benchmark that competitors will struggle to match quickly. What makes this truly a pivotal moment is how it changes the narrative around AI competition. Rather than simply trying to match OpenAI feature for feature, Google has leveraged its unique strengths to create something distinctive. This suggests a more diverse AI ecosystem may be emerging, one where different providers excel in different capability combinations rather than all racing toward the same universal model design. If Google can successfully build on this foundation, expanding the reasoning capabilities while maintaining the speed and multimodal strengths, we may look back at this release as the moment when Google regained momentum in the AI race. The combination of technical innovation, strategic integration with existing products, and deliberate accessibility choices creates a compelling package that addresses both immediate user needs and long-term competitive positioning.